For this activity, you have to either use GeoGebra if you want to, but it says a political campaign sends volunteers out into the various parts of the state to get a sense of how well their candidate would do in an upcoming election. 30 volunteers each get a random sample of 10 people in the state and find the proportion of people who are expecting to vote for their candidate. The sample proportion are summarized in the histogram, and they give it to you, and then it says the mean of the sample proportion is 0.55 and the standard deviation is 0.15. So this information is important, so I'm going to circle that. The mean right here is 0.55 and the standard deviation is 0.15. Another important thing is these 30 volunteers, and as you can see here clearly, you're able to see a normal curve. Okay. Now, I don't know about you, but I like to always create my normal curve. It's not difficult. You already have there that the mean is 0.55 and the standard deviation is just 0.15. So that means that this is going to be 0.70, this is going to be 0.85, this is going to be 1, this is going to be 0.40, this is going to be 0.25, and this is going to be 0.10. You create your normal distribution, and that's it. Now, let's see what they want. They say, recall that for normally distributed data, about 95% of the data is within 2 standard deviations of the mean. What percent of sample proportions are within 2 standard deviations of the mean for this data? So basically, you just answered it already. I mean, if it says 2 standard deviations within, that means that it's between here and here. Okay, and that will be there. If you want to use GeoGebra to do that, you can go and just click on probability calculator, and then 0.55 will say that it was your mean, and then 0.15 was your standard deviation. So now it's just a matter of checking to make sure that 0.25 is actually the number that works for this, and the other one should be 0.85. So I should get close to 85% here. And I do. That's close enough. So 0.95. Now, what percentage specifically? That would just depend on how you want to spread it. But, I mean, 95% will be almost 30 people, right? So, like, maybe 28 out of 30. 29 out of 30. I mean, if you do 28 out of 30, that will be, let's see, 28 out of 30 people, it's 93%. That's still pretty good. Okay, that's within the range of 95%. So we can say probably like 28 out of 30. And you already know that it will be 0.25 and 0.85 for the normal distribution chart. And that's about it. Okay, that's about it. Now the next one, it says estimates for population characteristics are usually given along with a margin of error. Now this is where they start to get technical here. Go back to the definition of population characteristic and you will see what that means. But margin of error, okay, think of it this way. When we talk about proportions, think of it as the mean. Okay, when I say sample proportion, that means mean. And when I say margin of error, I mean standard deviation. Okay, they are just in terms of variability. And go back again to the vocabulary if you don't know what that is. So it says the margin of error is the maximum expected difference between the estimate of the population characteristic and the actual population characteristic. So think of it this way. You come up with a number, an estimate, okay, maybe an average, that is not that accurate. But then after you run your tests and after you have exact numbers, you come up with your margin of error. And then you compare it to what you think it was the estimate. And then you say if it's a viable or it's a reliable number or if it makes sense. okay? That's all it is. It sounds really fancy, but that's all it is. So it says each of the sample proportions are good estimates of the population proportion. So we could give a margin of error that contains about 95% of the sample proportion to be reasonably sure that the actual population proportion is in the range between the mean minus the margin of error to the mean plus the margin of error. Once again, this is talking about the mu plus the standard deviation, but in terms of variability. So we use margin of error and population and the proportion. So it says what margin of error should be given along with the estimate of 0.55 for the population proportion. Now, I want you to understand something. Margin of error would always be twice as much the standard deviation. Okay? That's it. So, twice as much. Margin of error, it will be 2 times whatever the standard deviation is. So, if we go back here to the problem, what is the standard deviation? The standard deviation is 0.15. So, the margin of error will be twice as much. Okay? So, that means that the margin of error will be 0.30. And that's it. Okay, and we're talking about that because we're talking about 2 standard deviations within the mean. So one up, one down. There you go. And that's it.